introduction on what the w-iLab.t is. Then I would still try to do some hands-on things today. For those who want to participate in the hands-on part, it's best that you boot the computer in front of you. Because from your laptop, we have to set up VPN and stuff. So if you want to participate in the hands-on, just boot it. It should be booted in the Linux Mint, I think. The password, the user is practicum, and then the pass is practicum, but with an at instead of the a. Okay, so I'll start with a brief overview of what the wireless test facility in iMinds actually is. So the wireless testbed is part of the w-iLab.t technology center from iMinds. So you can see a picture here of the building. So this is the building where you are in right now. The w-iLab.t research center, so the actual data center, is at the first floor. If you're interested, we could go have a look later today. And there, for example, here one of these racks is the virtual wall testbed, which is the wired part of the test facilities here at iMinds, but which is not in the crew project. The wireless testbed, so we have two different locations. So one location is here, so the w-iLab.t office, we call it. So here we have 3 floors, and you can see one of the nodes hanging on the ceiling here. Both testbeds are heterogeneous, so we support both sensor network experiments and Wi-Fi experiments, or just experiments using even the fixed network if you would require. The testbed on the right, so the picture on the right, is about 5 kilometers away, and this is actually what the hands-on tutorial will be about. The hardware overview, so here you can see the embedded PC that is hanging on the ceiling here is a rather old one, so it's an Alex device with not much capabilities. And it has a sensor node attached to it. It's a T-Mode Sky sensor node, which probably a lot of you already know. So basically what this testbed, so the w-iLab.t office, is still used for is sensor network experiments. Because we have an extra limitation here that during office hours we cannot use the Wi-Fi. So most of the experiments run here are sensor experiments. Then the embedded PC we use in the testbed in Zwijnaarde is a little bit more powerful, so it has a dual-core CPU, 4 gigabytes of RAM, a large hard drive, and some wireless interfaces, which are of course most important for this project. So we have 2 802.11 ABGN interfaces, 1 Bluetooth dongle inserted into every node, and then we have a in-house designed sensor node. It's the iMinds Harmony sensor node. It uses 802.15.4, and you can basically compare it to a T-Mode Sky sensor node, but then with some more capabilities. It's a bit faster. It uses a newer version of the chipset, so it's a bit more powerful. Then we have an environment emulator in between, and then a webcam installed on about, I think now it's already 30% of the nodes. We use most of the webcams we use to point at the sensor node, so you can see actually some output of the LEDs. You can of course also, yes?
The environment emulator, what exactly?
I will,
sorry.
Yeah, I should have said that I will skip that because I have an extra slide. So yeah, T-Mode Sky and iMinds Harmony sensor node, I explained that. This is the environment emulator. So basically, so we have installed it here and in the testbed in Zwijnaarde. What you can basically do in a nutshell is toggle pins on the sensor node. So you can see maybe you have the parallel cable in between the environment emulator and the sensor node. You could say, for example, I disable USB of the environment emulator and I emulate a battery supply through that cable. So you could very accurately measure how much the sensor node uses, how much power it uses. Or you could even say, I emulate a battery that is slowly depleting. And then you can check on your sensor node, okay, now the radio is still working. What if my battery is only at 50% capacity. So stuff like that. Also more basic stuff like just toggling a user pin, so user input like pressing a button, you can capture that as well. So the node location, so here in the w-iLab.t office we have about 200 nodes. So every node we see as a combination of the embedded PC, so the Alex device in this case, with environment emulator and T-Mode Sky. Then in Zwijnaarde, one node is a more powerful embedded PC, so a Zotac PC, also with an environment emulator and the sensor. So this is the topology. So the left, w-iLab.t office, 3 floors. Every dot represents a node location, so about 200. And then on the right, you see the topology of the testbed we will use in this hands-on session. So it's a grid topology. Every blue node is an actual node location, so the Zotac with environment emulator and sensor node. Then here in the middle, these are some management extensions if we have to plug in some extra devices. And then here on top we have foreseen 22 locations where we can charge robots. For the robots, my colleague will give you more in-depth presentation tomorrow. So I will not go into detail on that. So you already saw this picture. So this is the testbed where we have here on about 1.5 meters away from the floor, we have installed the Zotac nodes. So about 60 of them. And you also see one robot. They are actually, it's an old picture. They are now mounted or stationed against the wall. The architecture and management. I guess I have to say something about it. So yeah, the extension, DNS extension, just for future reference if you would need it. If you want to access the testbed from outside, you need a VPN. So you can email Stefan for a VPN access. And then you basically have full connectivity towards your computer. This is how it looks like. I want to mention this picture. Maybe it's too much in detail. So this is the testbed we have in Zwijnaarde, and everything is connected over 100 megabit shared tunnel for all the users through our network, which you are patched into here. So if you patch in with OpenVPN, you patch into our network, and then you have to go through the tunnel. So keep that in mind. If you would like to transmit a large amount of data, you can do so, but it will be slow. Outgoing connections. So from the testbed, outgoing connections are not allowed. You have to go over an HTTP proxy, but most of the things you can relay over the proxy. Of course, we have, well, of course, maybe not of course, we have a different option. All the nodes in the testbed are, since a few months, IPv6 enabled. And there you have none of the restrictions which are mentioned above. So outgoing connections are allowed, you can do whatever you want, and you don't need a VPN. So if your network at office or at home is IPv6 enabled, that will make things easier for you. The architecture, yeah, so we basically have, I will go into detail on a few on the next slides, but we have a server connected to switches, and maybe the most important thing here to mention is the PDU. So it's a power distribution unit. It basically has, per PDU, it has 8 power outlets, and we can toggle the outlets to make the Zotac boot or switch it off. One extra feature we can do with it is measure the power consumption of the Zotac. Not very accurately, but still accurate enough to get an idea on what it is using. The rest I think I mentioned. The framework. The most important part, I think, of this tutorial is to understand how the different frameworks we use interact. So we have chosen to use Emulab. It's the same framework as being used on the virtual wall testbed, and it's basically used to provision your experiments. So provision, what do I mean by that? Is you load an image onto your Zotac nodes, but not only that, you make sure that you can reach them, so that they get an IP address, that they get a DNS name that you can easily understand, that they, if it is necessary, that you configure on the switches some VLANs so that the correct servers can communicate with the correct devices. I will show a slide next. So this is what the Emulab framework does for you. So it basically allows you to bring up a certain amount of nodes with your operating system of choice, and then you can log into those nodes. And that's where Emulab basically stops. That's why we have a second framework then. So it's being developed at NICTA. Oh, by the way, the Emulab framework is being developed at Utah in the US. OMF is being developed at NICTA in Sydney, which we had the pleasure to visit to get to know the system. And OMF, so while Emulab brings up your nodes and allows you to log in, OMF allows you to control the entire flow of your experiment. So it's basically, instead of logging in manually to the nodes and executing commands, you define a script beforehand and you say, okay, these are the resources I want to use, and this is the timeline of my experiment. So I will start these commands or these applications on this node, then 10 seconds later I will do this and this. And it also allows you then, in combination with a third framework, it's not really a framework, it's more like a library, which allows you to collect measurements in a uniform way. If we have time, we'll go into detail. The visualization toolbox, I will just quickly show this. So we have some tools. At the time they are Java based. There are ongoing efforts to put them into a web browser with HTML5 and JavaScript, which my colleague is taking care of. Basically what this does, it visualizes, for example here, the 3 floors of the testbed, and then based on an XML file and SQL statements, so in that XML file you specify SQL statements and you specify, so you choose what you want to show. So for example, you do a SQL statement and you say, okay, for every packet that is being transmitted from one node to another, I want to show an arrow and I want it in that color. Basically, it's all what it does, but it's a very generic tool. So if you have a database and you want to visualize some stuff, you can basically use this. Then you also have the ability to have graphs, export to CSV and stuff like that. So maybe more in detail. So this is one example where 2 nodes are sending at transmit power 7. So for TinyOS. And then you can see the different packets, the estimated noise floor at every node, and the RSSI. I don't know, where can I see it? Yeah, for example, here the RSSI value of the hardware extensions. Very quickly, so at the first floor we also have 4 boxes which are completely shielded from outside interference. It's integrated into the w-iLab.t office. So inside the boxes we have 1 node in each box, and instead of having an antenna connected to it, we have coax cables connected to it, which are through the back connected to this patch panel, where you can configure the attenuation between the boxes very quickly. You can, for example, emulate a very fast moving train, handovers between, so you define 1 access point in another, in one box, 3 clients in another, and you make them go really fast. So yeah, this you already saw in the presentation of Ingrid. One thing that is also installed in Zwijnaarde is the WARP devices. I cannot give you any details on that. It's basically, I think you mostly know more about it than me. These are the locations where they are installed. This can be interesting. So we have 6 USRP sensing engines installed at the moment on those locations, and then IMEC sensing engines on the red locations. This is a picture of a node with an IMEC sensing engine agent connected to it, and then we have a picture of the WARP. We had to put the WARP and the sensing engine in some boxes because there is some how do you call it, condensation from the roof. So it's not a lot, but it can happen that a drop of water falls down. So we don't want to damage the equipment because it's quite expensive. So mobility, as I said, So next to the 60 fixed nodes, we plan to add 20 mobile nodes. So basically the configuration is the same. So instead of configuring the fixed node, you will now configure a node that is on top of the robot. But for user point of view, there will not be anything different as far as management goes. Tomorrow morning, I think a demonstration and even a hands-on part. Emulab introduction before we go to the hands-on part. So what Emulab basically looks like in a nutshell. So you have one big switch, control switch, and you have two servers, one boss server and one ops server. Ops server is just a file server. So used to store your own files, used to store images, operating systems, whatever. And then the boss is basically the core server of the testbed. So it runs a DHCP server, DNS server, PXE boot server, and also the Frisbee. The Frisbee is used to multicast the images. So if you load 10 images or you load one, it will approximately take the same time, since the image will be multicast. And it also runs a web server, which you will log into in a minute. So we have 60 wireless nodes connected to the control network, and we also have 8 experiment servers, so hexacore servers, with each of them have 5 extra interfaces, which you can use to configure an experiment network. So on the left, the same control network, and then on the right, you could say, not for the Zotacs, because they only have one experiment interface, so they are just patched on the control network. There you don't have any extra interfaces. But here, the servers, you have 5 extra interfaces per server, which are patched to an experiment switch. What is also patched to that switch? It are the USRPs, the WARPs, for example, the CM cards from Nitos. What is not the IMEC sensing engines, because they are connected over USB to Zotac, so those are not connected there. And what you can do then is when you define an experiment, you can say, okay, I want to use a server instead of a regular Zotac, and I want to connect, for example, the second interface on server 1. I will put it in the same VLAN as USRP 6. Why is this important? Because the USRPs generate really a lot of traffic. If you would put it over your control network, it would probably saturate your entire network, and it's useless. So with this configuration, you can configure, for example, 3 USRPs to connect to this one, 3 USRPs to that, one WARP to another, and they do not interfere with each other. So it's not because I'm running an experiment with 2 USRPs transmitting at full speed. They are in a different VLAN, so they will not interfere with your other experiments. The file server, so I will hand out some sheets to the people who want to participate in a hands-on. So you can log in with the credentials, crew, and then training at w-iLab.t, but it's mentioned here on the sheet. One important thing to mention is that every user, so for you, this will be user crew, has its own home directory. And this home directory is persistent, so it stays there on the file server. And what is important is that this home directory will be mounted onto every node that you use in your experiment. So if you use 10 Zotac nodes, on that node you are able to access over NFS your user directory, your home directory. You also have a project directory where you can store files that are needed to share amongst other project members and accessible on your nodes. And Emulab projects, you can see them like Unix groups, in fact. The first Emulab experiment, so I will hand out the sheets for people who want to participate. Maybe you can work in pairs, because otherwise it might take too long.
Thank you.
If you don't want to participate, no worries.
Maybe I can also tell you that all presentations will be put on our website, so all the information there, we will make sure that everything is available. So.
So if you want to participate and your computer is not booted into Linux yet, do so now. Open up your web browser. Maybe I will. So open up your web browser, Firefox or something. Yeah, I prefer Firefox because I don't know. We need the Java plugin. And then browse to the first URL that is on the sheet. So w-iLab.t.iMinds.be. It's also on the sheet I gave you, if you can read it more easily. So when you access that page, you go on the left. So we created an account for you because it takes quite some time. Some people have called it the Holy Inquisition to request an account, so I guess that says enough. You click login, and then we are not way, so we put crew. And then for the password, it's also mentioned on the sheet, so it's training at w-iLab.t, and then you log in. Then you should get something like this. My colleague is also assisting in the back. Michael can also assist, so if you have any issues,
Shout.
if it goes too fast, shout. Oh, what was that? Oh, luckily it was the camera is standing there and not in the back. It would be broken now. So, what we want to do, we go to experimentation, and we want to begin an experiment. Right? You click that, begin an experiment, and then you say you have here the link new GUI editor. We go ahead and click that. It is a Java applet in the browser, so it is known to have some stability issues. So if it takes a bit too long, don't worry. You have to accept or activate the plugin, and then yeah, there we go, okay. Okay. All right. So then on the sheet you have. Maybe I should divide the groups first. So let's start here. So group 1, 2, 3, 4, and then 5 in the back, right? So 1 to 5 are here, and then 6, 7, 8, and then 9 for the final group. So for every group, I have assigned a channel and 3 nodes. I will act as group 14 now. And I will drag 3 nodes onto my screen. So 1, 2, so you just click it and drag it. And then for every node, it's easiest that you give it a name. So for example, node 0, I will rename now to access point. And before you click away, you assign the node. So in my case, it is Zotac K1. You fill Zotac K1 in the fix to node part, right? Now you do the same for node 2. So this is my client then. And I fix it to Zotac K2 in my case. Don't use the same nodes or we will get in trouble. And then, yeah, one backup node. It will not fail, so we don't really need it, but still. So you should have 3 nodes now. Fix them to your own nodes that are mentioned on the sheet.
Yeah, you cannot use the same notes as it.
Okay.
Use the ones assigned.
Now, in fact, we don't have to do anything else. But just in case you would like So now all the Zotacs are using the default operating system, so we provide an Ubuntu image with Emulab support, with OMF support pre-installed, so you don't have to care about that. If you want to use another image, it's possible. You just click here, next to OS, and you have a list of all the different operating systems that are available. But we will just go ahead and use the basic image now. Maybe I will mention this, but we won't do this now too, but for tomorrow it's maybe good. So I mentioned that if you want to use a server or a USRP, by default Emulab, if you say I want a node, it will choose a Zotac node. Because Zotac nodes there are most Zotac nodes, people who want to do wireless experimentation, they need a Zotac node. If you want a different node, you have to specify desires. So here on the bottom, you can specify desires. As I said, we won't do it now, but say for example, you want to have a server with 5 ports, you give it here a desire, I want to have a server with 5 ports, right? If you want to use RP, same thing, you say, I want this node to be a USRP. WARP, same thing. Robot, same thing. Okay, so we don't need that. So we will now go to the top left, click File, create new experiment. And then you give it the name that, for example, iPerf group 14, in my case, with the correct number. iPerf. And then you go ahead and click Create. Okay, already exists. Okay, my bad. I think I did a dry run yesterday, so let's just take group 13 then, because there is no group 13. You click, oh, okay. That's because I tampered with the weights, probably. You probably won't have this error. You probably succeed in any other case. Oh, okay. Does anybody else have issues? Already exists for? Let me delete that for you. So it's also a good, so for example, there is already an experiment called iPerf group 1. So now it has succeeded, my experiment creation, so for group 13. If I go to experiment list, I am in the cognitive radio project, so I can delete iPerf group 1, well, because I created it. Not everybody in the same project can delete people's experiments, right? But I created it yesterday, so I can delete it. And we are all using the same user account now, so please don't delete people's experiments. So if I do terminate, yeah. So if you try again, it should work now. Did everybody succeed? Everybody? Yeah. Okay. Perfect.
Except you.
Except me. Good point. So if I now go to experiment list, so here on top, experimentation, experiment list, I will first show it, then you can do it yourself. Well, I will take group 14 now, because I have those nodes pre-configured. And I say here on the left, swap experiment in, then it should give you an error. Right? You see the, let me make it a little bit bigger. So I do not have a reservation. Okay? So for the reservation page, we go to the same URL, so w-iLab.t.iMinds.be, but then /reservation. So just put /reservation after. You can log into that page with the same user account, so also crew and training at w-iLab2. And then you should get an overview of all the reservations that are planned for the wireless testbed in Zwijnaarde. Now, for example, you see the first entry here starting Saturday the 11th of January until tomorrow evening is from the user. This is actually Stratos from University of Thessaly, who will demonstrate, or we will demonstrate it for him, I think, an experiment with the Nitos CM cards. So this is a list of all the reservations. If you want to get a node overview, you have a page here with the different types of nodes. And for example, if we go down, we have here Zotac nodes. Yeah, well, the resolution is prehistoric, so you see that Stratos, for his experiment, he reserved these nodes. The names of the nodes are related to, so you saw this picture, so it's always Zotac and then the name of the location. So column A, B, C, D, E. So you know that E2 and E3 are next to each other. D3 and E3 are next to each other. I mean, it gives you some idea of the node locations. So if you click here, the free nodes, you can see that most of the nodes are free. We of course reserve them for you. So now you have created an experiment. So using this experiment, you go again to the reservations page and you click new reservation. New reservation. Start time will be automatically filled in for you, even if we take 3 minutes, doesn't matter. End time, I don't know, let's say 12 o'clock or something. And then you have a step to choose your experiment. And now you choose, of course, your own experiment. So I will reserve group 14. And you click reserve. And you see it is added. I see that group 9 is in there.
6.
Group 3, 1. Now what this system will actually do is it will check every minute to see if there are reservations that are starting now or in the last minute, and it will automatically activate your experiment. So here I perf group 14. If you click your experiment, so if you go to experiment list, you click on all, you see group 14, you click it, you can see that it changed, so you can cancel it, cancel experiment swapping. We won't do that obviously. So now in the active experiments I can see that my experiment is active, group 9 is active. Let's check the reservations. It can take about a minute, but you can see, I think most of them. Group 3 is coming up. Anyway, in the meanwhile, while we wait for the experiments to be activated, if you click your experiment, you can see some details of it. So you can click the visualization. You see we only have 3 nodes. The visualization only becomes interesting when we have servers connected to a switch and USRPs, or you have more complex topologies. For now, we just have 3 nodes. You also have an NS file, good to mention. So if you don't like working with the Java GUI, you can just use NS, so the network simulator language. Basically quite easy to understand, it's just getting to know the syntax. And then the details of the experiment, which is most important here, is that you have a list. So you have a list of the nodes that you reserved. And then you also have the DNS name. So you can see, for example, you called your experiment access point, your one node in your experiment access point. You will see that it will get the DNS name access point dot iperf group 14, my experiment name. So node name, experiment name, project name, cognitive radio, and then the extension w-iLab.t. Okay, so let's check how everybody is getting activated.
How do you activate the node?
What's that?
How do you activate the node?
So the node, so did you make a reservation? Okay, let's check if it doesn't go automatically. But you can click swap in experiment. So swap experiment in on the left. Yeah. And also, while activating your experiment, you can see the activity log file, and you can see if there is something that is going wrong. So you can see it, it tells you basically everything it will do. Send a PXC, wake up to that node, reboot. Zotac is alive and well. Okay. So I guess if I see it, most of the groups are active now. If you want to check the status of your experiment, you click your experiment, you browse a bit down, and you see the nodes you have, and you see their status. So if they are up, you should be able to ping them. Now, if we open a console, just log into the, I think the DNS will fail here, so it's good that you log in first to the third bullet here on the sheet. So OMF EC, just log in with the same credentials, and it's IP address 10.11.31.6. So it's the third paragraph on the sheets. So first log in there with the IP address. So crew at SSH crew at 10.11.31.6. Password training at w-iLab.t. Not working?
No,
Okay. 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 So it hasn't been activated yet. So probably too many experiments on the same minute. So if you just swap experiment in, click confirm, and should be getting activated.
Yeah. Was overloaded.
Probably, I think. I'll have to check. It hasn't been operational that long yet. So I think 6 experiments got swapped in at the same minute.
Yeah.
Yeah, it's not too bad.
Stress testing.
Stress testing. Yeah. It's only now that you get these. So now, if you are logged in